is when the virus infects the cell, but no new viruses are made. And what happens instead is the virus splices its genome into the host cell's genome. When that host cell reproduces, all the daughter cells are also going to have that viral DNA within it. And it may just stay that way for a very, very long time or forever. But there are things, and exactly what triggers this has not been entirely figured out. But some cells that have the viral genome spliced into them, the virus can reactivate and go into the lytic cycle, and then we get viral replication, and eventually, the cell dies and new viruses are released from that. So some interesting examples for these things. The chickenpox. When I was a kid, they didn't have a vaccine for chickenpox, so everyone got chickenpox. I got chickenpox when I was 6, and I remember it really well because of a lot of things. But one, it was a very uncomfortable disease to have because you had all these like pock lesions all over your body. I mean, everywhere, in your mouth, everywhere on yourself, and it was very uncomfortable. And I remember my mom putting me in a bath of like I think baking soda or something like that to try to prevent me from itching it and things, but there was nothing they could do for you. There's no drug to give you, just you and your immune system against that. And in some instances, those pox, because you got lots of them all over the place, can become infected. And I remember there being, not when I had chickenpox, but when I was a little older, I think I was in high school or something. I remember seeing on the news a child who had gotten chickenpox, and then some of those pox had gotten infected with a bacterium. And they wound up getting sepsis, which can kill you, but the person was lucky they didn't get killed, but they had to have both their arms and legs amputated. And so, there's those, even though most kids, get over it, like I got over chickenpox. And then you had all these pox on you that were healing, and I actually had some scars on my face for a long time due to that. But that chickenpox virus is still in me. So it is in the lysogenic cycle right now. So once you get infected with it, you've got it for your whole life. And some of you may be young enough that you got to have the vaccine rather than getting the actual disease. And so later in life, it might reactivate in me, and then it comes out in disease, what's called shingles, which I've heard is even worse than the original chickenpox, and it's very painful and goes on and on. You can spread it to others who haven't had chickenpox, so you give unvaccinated kids or other people who haven't had it, that virus, if you are having shingles. Fortunately, we do have a vaccine for this now, so our kids can get vaccinated instead of getting chickenpox itself. And they have a vaccine for us older people. I think, I'm not sure what the cutoff is, maybe like when around 50 or so, you can get a vaccine that reminds your immune system to keep that virus suppressed. So it's supposed to help prevent you from getting shingles. And so, which I have gotten that vaccine. I got that vaccine maybe 3 years ago. In diagnosing viral infections, usually there isn't culturing that's done, because then you need the host cell for it to reproduce in, and that's not generally something feasible in most laboratories. So there are a number of ways that we can diagnose viral infections. I think we all have become more educated just because we've heard about it in the news all the time for a while. There's the antigen testing, where they're detecting the actual virus itself using antibodies in a test. And we'll learn more about that in our last unit of our coursework. We'll learn about immunology and immunological tests. And then PCR, of course, is more familiar to you because we've already learned about that. That was another test that can be done for COVID, HIV, and others. Some viral infections, they just say, okay, you've got cold or you've got chickenpox, and there's not like a lot that they can do for you anyhow, so there's no sense in testing you for it. But if it's something that it's useful to test you because we either have some sort of drug we can give you, or we need to know that you have it so that you isolate yourself from others to not spread it, then we would do the testing. Now, some testing though involves actually looking at cells that might be infected. I showed you, I think on our first day in class, lung cells that had become infected, and the cells that become infected look different, and those are called cytopathic effects. The human papillomavirus is a sexually transmitted virus, and it is probably the most common sexually transmitted disease that's out there. And it actually causes cervical cancer and cancers of the head and neck. And we actually have a vaccine for this now. But the reason it causes these cancers is because it splices, when it does the lysogenic cycle, it splices its genome into cells, into our cells' genes that regulate the cell cycle. So for instance, in our body, certain cells are reproducing really fast because they need to be replaced, like your skin cells reproduce fairly quickly, especially if you get a cut, they're gonna reproduce even faster, whereas others reproduce very slowly. And that is tightly regulated by genes in the cells. If that gets unregulated, then cells can start to reproduce when they're not supposed to, and then we wind up with a mass of cells there, and that would be a tumor. And then sometimes some of those cells can break off and go somewhere else in your body and form another tumor, and that is cancer. Cancer is your own cells reproducing when they should not. And this is oftentimes happens when these genes that regulate the cell cycle get messed up. And one way they can get messed up is getting infected with the human papillomavirus. And so what used to be an annual pap smear that women got, where they scraped off some of the cervical cells and sent it to the pathologist. The pathologist would look at those cells under the microscope to see that they look normal. Because in the early stages before it's cancer, you can start seeing the cells not looking right, and so obviously the sooner you do something about something, the better the outcome, the possibility of the outcome is for you. Today we also have PCR tests for the human papillomavirus, and so if you haven't had abnormal pap smears and you're with a negative PCR test for the human papillomavirus, then you don't need to do the pap smear nearly as often. And since we've had the vaccine for some time now, I think at least 10 years, it might be a little longer than that, we're starting to see a reduction in the cases of cervical cancer due to that. Smallpox is a disease